Hello, everybody. We're going to be starting now. Our current talk, what we're going to be talking about is about scaling Dagger and how DI works in this new modular world that we're living in. So first of all, we're going to start with a couple introductions. It's this handsome fella on the left-hand side. It's me. Not you. It's me. My name is Nacho. I'm a software engineer in the Instantiating Architecture team. I know it's a mouthful. And that's my Twitter handle. Don't ask. And yeah. And this handsome fella as well is César.
I don't need the microphone.
Okay.
Can you hear me? Okay. So let's get going. I've been on Twitter for 7 years, and I've been working on Twitter for Android for the last 5 years. I'm the technical lead at the team. So you could say that I can see quite a lot of how the application has grown through this time. Now, what we are going to do for just giving you a bit of context is to take a trip down memory lane back all the way to 2010, and then where it all truly started, and then show you a bit about how the application evolved through this time. So initially, this was it, one single application, app Twitter. With Gradle, with the advent of Gradle, we broke it down into a library because everyone knows that it is important to have libraries. But that was it. That was the whole of the application back then. This is dark times in 2014, 2015. We broke off one portion of app Twitter into a features legacy module. That was essentially the whole of the application in that single module, and we called it legacy in the hopes that, well, that would encourage moving out of it. Now, that did not happen overnight, but we continued working on pulling out pieces, a core layer at the bottom that's essentially just all of the components that are not Twitter specific that we could potentially share with other applications. Then features, like I said, we started pulling off features out of features legacy into individual modules. At the bottom core, we're going very fast here. I'm like, this is obvious, right? It's not totally so, and Nacho will go into some details on some of the complexities of doing this. But essentially, we broke down the core into individual libraries. Then same thing with the Twitter layer. We broke it down into infra libraries that are essentially reusable but tied to Twitter. Then subsystems that are larger systems that are shared by the features. And eventually, and I will admit that we are not quite there yet, we will get to a world where an application is broken down like this into individual modules, but each one of the features has its own separate modules. Now, later, this was 2015. Periscope joined the flock, as you say, and we brought them into the same repo. But you can see that it fit right in with the lower layer being available for Periscope to use straight away, and the Periscope infra shared across the two applications. Once we got this, we may as well add others, sandboxes, feature teams that want to build their feature in a small isolated application. They can build a sandbox if they want on the same infra. And I won't say that's entirely trivial, since maintaining the dependency injection graphs is costly. But it is certainly a possibility. We'll see how we can make it easier. And that's essentially where we are. Now, something that I would like to highlight is that this model of application that we're just describing, it's not really driven by scale. It's not like you will only do this if you're Twitter. You have 1 million lines of code, otherwise it's not worth it. We believe that this model of application would be useful to any application. We hope that what we are going to be discussing in the rest of the presentation will be useful to anyone of you. And with this, take it away.
Taking the torch. Okay. So let's talk about dependency injection a little bit. Dependency injection is important, and it's important for a number of reasons. I am going to just list a couple of them, but not going into much detail. There are like other thoughts about it. It improves reusability of the code, improves testability of the code, helps with correctness, and allows us to refactor things easier. But what's good here is that DI is important, and it doesn't matter the size of the app, like César was saying with the module. So a little show of hands in the room, who is using some form of DI in the app? Okay, good, I'm very proud of you. So, of all of you, who is using Dagger? So most of it.
Oh,
so it turns out, I'm not surprised, and thank God that you are raise your hand, because otherwise it would have been for naught. I'm not surprised, because DI is important, and we can obtain benefits right away from adapting it, right? And within the DI world, Dagger is a good solution for medium to big-sized apps, and it scales reasonably well. And probably the biggest benefit, the biggest selling point for Dagger are all of these really nice static checks that it provides. So it's always going to be better to have things failing at compile time rather than in the hands of your users, right? Like being told at compile time that you're missing a binding or you have duplicate bindings, it is so much better than encountering these while the user is playing around with your app. Another good upside of Dagger is that it generates a ton of code, but especially the boring code. So Dagger helps us with automating what's really boring about manual DI, honestly. So if you take a look at these, there are like 3 classes here, but then that translates to 4 lines of code for instantiating them. What happens if you modify one of the constructors, you're going to go over and having to change a lot of code. And you can imagine that this doesn't scale really well. So with Dagger, we can just slap at inject on things and get done with it. Like all that boring stuff goes away. And Dagger allows us with scopes to create some scope groupings of objects, right? And these scoped objects, we use them to be able to map to be able to model app life cycle to them. And just a tiny disclaimer, over the course of this talk, we're going to be mentioning a lot the word object graphs, because it encompasses like component and subcomponent, and to be honest, the word component is like maybe not the best word. It's very easy to reuse. So let's go to, let's switch gears a little bit, and let's see how we implement our graph architecture at Twitter. First of all, we have like the biggest scope, the one that starts when the app launches and dies with the app, which is called the application scope. It will contain all of those singletons that we just want once over the course of the app. Then we're going to have the user scope, and this scope starts when a user logs in.
Is it a loser?
Don't quote me on this, please. Don't tap me. So, English is hard, come on. So we have the user scope, and it starts when the user logs in, gets killed when the user logs out, and then some other user logs in, like we have a new instance here. Then we have something that we haven't seen quite a lot around there, but we have what we call the retain scope. And these supposedly map to your let's say like your feature streams. Like whenever you see like something in a screen that's for activity fragment or whatever, and this graph, the particularity it has is that it's retained across configuration changes. So namely, if you rotate the phone, this doesn't get recreated. This doesn't get destroyed. A common use case for it would be to put like view models, like the concept of view model, not 100x view model, but you get the gist of it. It works all the same. And also like things like repositories, use cases, whatever. And then inside of that scope, we have what we call the view scope. And this is the one that's closely tied to the life of your activity or fragment. And typically it's going to contain your activity or fragment context, the views, and a lot of other bindings. So Dagger lets us annotate these scopes with some custom annotations. And these are the ones that we use canonically at Twitter. So as to we use components and subcomponents, we start the application object graph starts with a component, Then we reference the builder or subcomponents in the object user object graph, which then we reference. Here is only one, but we can reference like many of them, subcomponents for our retaining scopes, one for each like screen or like grouping. And then that maps to another subcomponent for the view scope. And you might be wondering why we chose components for a graph, which is the application scope, and we use subcomponents for the others. So with Dagger, and you might be wondering about this because there are hidden costs on using subcomponents, like compilation times might be longer, and the control of visibility is an issue as well. But we're going to see more on this later. But using only components for all the graphs really doesn't work in a modular world, because on a component you need to reference the parent component from the component itself, right? So it makes them hard to scale. So we only see people using components for everything in big companies that have been creating their own solutions to manage this by generating some code. So far, we talked about our modular architecture and our graph architecture. So if we combine both things, we can see how we distribute our graphs in the module hierarchy of the app. So on the left-hand side, we have our module decomposition. On the right-hand side, we have our graph architecture. So something that looks ideal would be to put the application user graphs down at the bottom. And we would then assume that all our infrastructure layers are the ones that are only going to be providing bindings for these object graphs. Let's see if this holds up with an example. Let's compose a tweet. So there's a very beautifully crafted tweet from yours truly that says, "Hello, my tweet," puts like a picture that I took from Google. And let's see where things are in here. So first of all, we start from a feature module that has the composer feature code. We will have an activity, a view model, a view delegate, view holder, whatever you call it. So all these bindings will be around here. So, so we have this subsystem views layer down here that will have a user scope binding for Twitch repository. And then we after a problem. Like we are.
Use this for a while. This microphone doesn't work.
Oh my god. Okay, okay. This is not awkward at all. Like we planned for this. We planned for this.
We are a team here.
So César,
hi.
This is going to so work. Like yeah, keep going. So encounter our first problem. Like we cannot have the user scope so far down, and it would be common to have user scope bindings in upper layers, like this subsystems layer.
That's working.
Okay.
See? No one noticed.
No one noticed. Nice. So this forces up. I'm sorry. Like I will go through this again if, or later I can explain more. So this forces us to move the user scope up. And we are going to see another example for another scope right here. Like for example, if we have this idea of image uploader in a lower layer, this binding is application scope. And of course, because the application scope lives down there, like we cannot see it, so it doesn't really work for us. So we are kind of forced to push it up. And then we have like some other bindings, like for example, the network. But what happens if we have this idea of a notification handler here living close to the composer code? For example, you press the tweet button, and then after a while, you receive a notification or a snack bar or something that tells you, hey, the tweet has been sent. You might be already in the home timeline. You are not waiting. You're so not waiting in the composer, because that would be awful. So that kind of forces us to move things up there. To the top Gradle module, the one that has like the application entry point. Same when we talk about these bindings being spread out, we kind of imply that the modules are also spread out, because some bindings might be defined with @inject annotations, but some others are going to be defined with @provides or @binds. So our first naive distribution of graphs look like this, but we've seen that it doesn't really work if you have a modular app. So the ideal location naturally becomes that the app-wide graph definitions, like application or user, have to get moved up. So we fixed a problem with the location of our graphs, but I'm afraid we kind of stumble upon a new problem. If we think about how these graphs might look like, they are going to become huge. Right now, we are in the top Gradle module. So we have to reference like all these Dagger modules down there with some bindings. So we can see that, yeah, it can be quite big. And it scales, like it grows really, really fast. So I have a problem. We need to reference bindings. We need to reference Dagger modules. We need to reference subcomponents builders. And it's difficult to maintain because references are scattered through all the Gradle modules. So how can we fix this? What if we were able to separate those definitions in tinier digestible chunks? And what if these definitions were collocated so in the same Gradle module as the bindings? And this is what we call a subgraph. And a subgraph is nothing more than a slice of an object graph. It allows us to partition these big graphs, like the application graph in this case, and into smaller subgraphs and move them to the Gradle modules with the bindings that they represent. So for example, let's see how we would break down a slightly smaller, for the sake of you being able to see it, graph. So for example, we'll take away the composer app subgraph into an interface. We will have application object graph extended, and we would move this new interface to features composer. We would do the same thing for everything. Like for example, for these things about the tweet repository, we will move it to the subsystem of tweets. Then the image loader would be moved, and we would add the subgraph to the extension list of the application object graph. And same thing for the core network stuff. So things would keep on working because it's just an interface extending other interfaces, right? Like that, we can do that. So sounds good. And the graph then becomes more manageable because all those bindings will be grouped, and they will be collocated in the Gradle modules where the bindings are at. So overall, breaking down the big monolithic graphs would eventually look like something like this. So all the big graphs that we have would be, all those definitions would be separated into like different modules. So we had a tiny problem with these big graphs that could grow very wild. So if we scatter those definitions into the Gradle modules where they belong, we don't have big monolithic graphs anymore. So we mentioned how the different graphs map to the life cycle of our app. And we talked about the distribution of graphs. But how do we really use them? How do we go about instantiating them? So typically, when we are going to instantiate the graph, like the application component in this case, we use its builder. And there is a slightly annoying thing that for all of you that raised your hand when I asked about Dagger, I'm sure you feel it too. That class is generated. So it forces you to actually compile the app to have a reference for it, so Android Studio doesn't complain about it. So what if we could like fix it? It should be fairly easy, and it should be low-hanging fruit for us, right? Like, so let's do it. What if we changed it for like a static method that would just reference the actual component? What if we had some utility class that could infer the component name from its builder? And I'm going to use the R word for this. I'm going to use reflection. Yeah. But we're going to just use reflection once. So we're just going to, don't worry, don't take pictures or anything. But TLDR, we're going to use reflection to go into the component. We know that there is an annotation there that's component builder, so we'll find it. Then we instantiate whatever class has it, and then we look for the builder method. That is always the same. It always has the same name. And don't worry, we're going to share this code. It's just boilerplatey, but it didn't fit in one slide, so that's like no. So we had this tiny issue about generating, referencing generated code. And what's better than doing that is not referencing generated code, even if we use reflection once on the whole life of your app. I think it's pretty reasonable. So then, given the big graphs are in the top layers, what if we want to extract some objects from intermediate layers, so things that are below it? And all of these things that we talked about, subgraphs, like might look like silly thing to you, this is where they come in handy. So a typical example of needing access for this are for obtaining classes from outside what's managed by Dagger, obtaining classes from inside of Dagger. So typical example is you have this legacy activity that doesn't have any injected stuff or anything, any Dagger configuration done in it. And we want to grab this image uploader thing. So we have a problem, is that we can see image uploader, but we cannot see the application object graph that we talked about, right? We moved it up for a reason, but we don't see it because we're down there. What if we were, instead of referencing the actual binding, what if we reference the subgraph? Let's see how we can live doing that. What if we have like a silly wrapper for graphs? We could just change this code that we had to grab the component and then put it in this static getter, right? Like it doesn't matter, it's application scope, it dies with the application, right? It's not going to create any leaks whatsoever. So then, because this provider doesn't know anything about the application object graph per se, it's any, like you could have anything in there. It can live down there. So in this case, we see that legacy activity could see the subgraph, and the module that has the subgraph could see the module with the provider. Then to access this subgraph, we would need to just cast what's returned from its provider with a cast. But we can do better than that. What if we just move all that casting thing away from like our developers? So we could just create this getSubgraph method and do the class, the cast inside of here. Then we can take things a little bit further. We can modify our media app subgraph to have this companion object that we just grab the provider and get the subgraph out of it. So it does the cast for you. Then the TLDR of all of this mambo jumbo is that you can just grab the uploader directly by referencing the subgraph and grabbing it. And this would go to Dagger. It would take the same instance that Dagger has. So you can use it for your stuff. So we had a problem with getting instances from the graphs from within legacy code, but we fixed it by grabbing the application and user graphs. So let's see what we've done so far. We moved the application and user graphs to the top. We distributed the subgraphs into the Gradle modules. So we don't need to reference the global graph anymore, but just reference the concrete subgraphs instead. So how would that work in testing if you were to hit that like media subgraph, whatever, .get? Well, you can slightly change the implementation, adding a way to override it, and then when you consume it, return the overridden one, otherwise you go to the normal one. So then, we've been talking about feature modules already, and we can improve the experience of working with them by using Dagger, by decoupling these feature modules. So namely, we're going to talk about app navigation. So in a modular app, we typically have our features in separate Gradle modules. So we have this composer, DM activity, main activity, whatever. So how we can start these activities that we cannot see? Because, for example, from a DM, you can receive a tweet, and you can tap on the tweet and open the tweet detail, right? But from tweet detail, you can press on a button and send a DM with that tweet. So how are we going to go about launching those activities if these two modules are in a circular dependency? right? Like if you import one to one another, like that doesn't compile, it doesn't make sense. So let's work a little bit with our modular design. Let's separate the intent creation logic into some sort of intent factories, which we call at Twitter activity args for activity arguments. Then we move these intent factories down there to a navigation subsystem, so just a tiny module that has like all of these factories. And because this is intent creation, like you're not going to have like any extra dependencies there, like you're not going to have like dependencies between one another, right? So we can move them there. So all of our feature modules are going to launch an activity. They just use this. They reference this Gradle module. So we have this interface that creates an intent based on a context and the class of an activity. And then, like for example, in the composer case, we have a way to creating that intent. And we have a way, it has like a slightly good side effect is that we put extra with these random strings, just centralized in one place. And as I was saying, this is nothing more than a factory of intents. But we need to be able to aggregate all of them. So we need a service discovery mechanism. So in Dagger, those are multi-bindings. So the idea is that we would add a multi-binding for every activity arguments class in its Gradle module. So Dagger would create a binding for a set or a map, depends on the type of multi-binding that you use, and aggregate them. So in our case, it would be aggregated in a map. So we would have a way to tie the activity arguments, so the intent factories, to their own activities. Because this adding to these bindings is going to happen in the same Gradle module that has visibility over like the activity and the arguments class. So how does this look like? So well, in our Dagger module, we could have like a multi-binding. We can tell Dagger like, hey, this is going to go in a map. It's going to have this class reference as a key, and it's going to have this activity reference as a value. So then we could create a helper class that would just take the map that Dagger created for us and be able to start the activity based on just the activity arguments. So we would just call to the factory, provide the context that we have, and extract the Java class from the activity args, from the activity map. So that way we have the reference from the actual activity. So we would be able to start the activity then. So we had this issue that we couldn't start an activity that we couldn't see at compile time. But while at compile time you might not see things, once you build your app, everything is there at runtime, right? There are no barriers there. Dagger does that for us. So what other things could we do following similar strategies? We've seen some concrete examples, but we can use it to couple some other concepts. Like for example, we can talk about initializers. So typically, like for example, like you might want to, when your application starts, you might want to start using your Google Analytics, or you might need to, you use Fresco, so you need to initialize Fresco or your room or whatever that you're using. So we can use some multi-binding set to aggregate the objects that take care of that initialization. And just by the trick of accessing that multi-binding, Dagger is going to instantiate all of those objects. So you can take that into advantage. You can take that particular thing into advantage and get all this initialization code going on. Also, we can use notification handlers in the same way. We can have like aggregate them by using multi-bindings. And same thing can be applied when using deep link handlers. So we've seen some common problems that arise organically when your modular app grows in size. And some solutions we implemented at Twitter for them, like for example, distribution of graph declarations in subgraphs, direct access to any object in the graph, and the complete encapsulation of a feature module, like for example, how to start with the way of starting activities, using initializers, etc. I'm going to pass this to César because he has some more things to say.
Take it over. Just wrong. So we got to a fairly decent place. We broke it down. For the most part, we've broken down the graph. We distributed them to modules. They're somewhat encapsulated, but there are a number of problems that we glossed over just because we did not have a good solution for them with whatever functionality that Dagger was providing out of the graph, out of the box. So this is where we were 2 years ago, and we found ourselves struggling to figure out how to address those. So let me talk through some of them. Subgraphs, they're not really atomic units. So we did better with localizing them to the modules. We have subgraphs distributed to the modules. We have Dagger modules as well distributed to the modules. But then we have all of these direct dependencies. You saw that graph that Nacho showed earlier. This is exactly what it looks like, right? We have all those references at the top to every one of those subgraphs, and everything is coupled in a way, right? Like everything is coupled statically in that every single subgraph is referenced directly from the top, which is not great. So subgraphs in particular, you see, we had a particular subgraph that's shared by 2 applications, which we are doing it more and more extensively. We found ourselves in this situation where now any change that we make in the subgraph needs to apply multiple, needs to update multiple graphs. Imagine that we had sandboxes. This gets crazy very fast. So what if we could associate that module to the subgraph instead of so that bringing the subgraph into the graph brings the module along with it? Let's see what that would look like. This is what it looks like now. And this is where we are, right? So we would start by making interface and making subgraphs a first-class citizen. We'll say this is a subgraph in this new imaginary system. It's in the application scope. And then the module we would reference directly in the subgraph, right? Now, if we go to the object graph, we cannot use component anymore because it doesn't know about subgraphs, right? But we could certainly replace this component annotation with an object graph annotation that does not need to reference modules anymore because they are already coming through the subgraphs. This is what it looks like with a subcomponent, exact same thing. So we have these 2 annotations, and of course, we could use an annotation processor. We crunch them. We generate the exact same components and subcomponents that we were manually writing before. So this is entirely compatible with Dagger. We don't have to do the whole conversion at once, since who wants full migrations, right? So this is one nice first step. It's still not entirely great. Like subgraphs are still not encapsulated. I could potentially attach any module to any subgraph without an enforcement that the module needs to fulfill the bindings in the subgraph. Yeah, is this whether this subgraph is valid in terms of does it contain the right modules or not? I would only know once I put them all together in a single object graph, right? And this is you're probably seeing it all the time. Even if you distribute the subgraphs to you were to distribute the subgraphs to your application, you still validate it at the top. Now, wouldn't it be great if subgraphs could be validated individually in the modules where they are? So that here we are declaring a bunch of dependencies. We could actually declare dependencies with other subgraphs. And with this, an annotation processor should be able to validate that whatever it is that's referenced inside of this subgraph is satisfied by those dependencies. If we were to do that, we could then truly encapsulate subgraphs in a way that the validation of your definitions happens inside of each particular module, not at the top. When I get an error at the top, I typically that's typically referencing a huge chunks of the graphs I know nothing about. So being able to do 5 minutes, I'm doing well. being able to validate it on every graph sort of solves that on every module sort of solves that problem. So it's getting better. Subgraphs are not self-documenting, and this is a problem that we get with Dagger all the time, where when you want to understand how to use a bunch of Dagger definitions, well, good luck. You probably need to go spelunking into the implementation, trying to understand what's available, and more typically, you will just try to make it compile and fix errors as they happen. And that's a problem because the definitions, the subgraphs themselves, they're not really self-documenting. But that's not really the case anymore. Because if the subgraphs are validated, then you can trust that the interface, like in here, is giving you everything that you need to know in order to consume this subgraph. It's telling you these dependencies, but more importantly, it's telling you that all of that is entirely validated, so that this is all that you need to know about this subgraph. It provides a broadcast controller and nothing else. This, you would imagine, that could be very helpful for an IDE integration, since the same information that you can trust from that interface, an IDE would be able to consume in order to present it to you with autocomplete and that sort of thing. One last thing that we sort of glossed over as well. We listed you see this, the full list of graphs. You may have hundreds of subgraphs in your application, right? We group them together with modules, but we still have this. We still have our application graph listing all of the subgraphs, which is still very hard to maintain. If I were to share multiple subgraphs across applications, I would have to manually go and find which subgraphs are visible from each application, right? It's quite insane. So maybe we can use the annotation processor as well. And then what we would want to do is to have it find those subgraphs for us, so that the declaration of these subgraphs, the visibility of this subgraph in the top module, should be essentially all that you need in order for that object graph to be configured for you. And what this means is that building the object graph it becomes trivial, because it will just aggregate all of the subgraphs. If I wanted to share those subgraphs with another application, with Periscope, it will figure that out for me. If I wanted to use it sandboxes, I wanted to use a sandbox that consumes just one portion of the stack, it will find whichever subgraphs that are relevant to that portion of the application and configure the object graph for me without any extra work. So that's kind of addressing all of the problems that we have alluded to so far. But since we have this subgraph, this subgraph sort of a new type of entity, and we are kind of imagining what a next generation, so to speak, dependency injection system would look like, we can explore some more. What else can we do? And something that we found is that subgraphs are not reusable. Have you ever tried reusing a module in Dagger? Like, you have your module and you want to put it in a library in a way that it can be consumed by multiple applications. Good luck with that. For the reasons that I mentioned before, the subgraphs, they are not the modules themselves, they don't really provide a validated interface, right? So it's not really designed for doing that. But our subgraphs are. So let's say that you have a core network subgraph that offers these components, right? We could use that. We could reuse that directly in Twitter. But maybe Periscope needs another cache. So what we will probably have to do is to rewrite the subgraph by replacing and rewrite the module, something like that, replacing the cache, right? But if we were to be doing this as in an object-oriented programming setting, that would be very easy. We would just make the class open, and we would make the cache open, and we would override it, right? So maybe we can do a similar thing with subgraphs. And we can just declare our Periscope subgraph by reusing the subgraph that we already have, and by just overriding. You see, this is an override of a binding that we always wished Dagger would offer. But it seems to make sense, right? That I would want to reuse whatever I have already so that I can share it with Periscope. Something a similar vein. We have dependency inversing of dependencies. We usually use abstract in an object-oriented programming world. If we want to declare that something will be declared at a later time, we can sort of do the same thing. We can declare my subgraph as being abstract. And this is just saying this is a template for how to build a subgraph, where all that you need to provide at a later time is, oh man, the pressure is on. where all that you need to do is to define a subgraph at a later time that overrides the Twitter schema. And yeah, there's a lot more that we could do here. We could do native assisted injection. We could optimize build times, since we are no longer building everything, running all of the computations at the top. We're distributing the computations to the modules. We could do integration with the IDE, like I mentioned. And this annotation processor, well, as you would imagine, it does have a name. And this is what the solution that we've come up with during this last couple of years for addressing all of these problems and taking us to a world where we can fully decouple all of the modules in a way that the application is made of entirely isolated modules. It implements all of the features that I mentioned. A few more. There's a lot more in the pipeline, but we didn't have the time to cover, since we're running out of time already. And this is coming. This will be open source sometime in 2020. So we'll be looking for feedback. We'll be looking for early adopters. We are hoping that we can help make things easier for people using Dagger. And as you can see, there are a lot of you. And yeah, if you have any questions, you can find us later, since there is no time for questions now. But thank you so much for your time.